Hello students, welcome back. I'm Dr. Bimal Srivastava, Associate Professor in Department of Applied Science and Humanities. In this lecture, we will discuss third part of our PI, that is how to find particular integral of ordinary differential equation of second order or higher order with constant coefficient. So in our previous videos, we have discussed PI when our fx function is either exponential function, that is e raised to power ax, or some trigonometric function, that is sine ax or cos ax. In this video, we will discuss PI when our function, that is our right hand side function fx, is of the form x to the power m, that is this is a polynomial of degree m. So again, general form, our equation is f d y is equal to fx. For finding pi, we take this fd in the right hand side, so it becomes 1 upon fd into x raised to the power m. So what we do now here, we take the lowest degree term in this fd as a common, so the remaining part becomes some function of like this 1 plus phi d or 1 minus phi d. That is phi d is function of d. That means once we take some minimum degree term common, so the first term becomes unity. That is we reduce this factor fd in this form after taking some lowest degree term in common. And then we take this factor on the numerator and expand it with the help of binomial distribution. And after expanding it, we simplify our expression. So for example, let us suppose we have an equation d square plus 5d plus 4y is equal to x square plus 7x plus 9. If we see this, this is a polynomial of degree 2 here. So here I am not considering again CF. For PI, this is our capital FD. We are taking this FD in the right hand side. This becomes 1 upon d square plus 5d plus 4 into x square plus 7x plus 9. So as I told you earlier, we take the lowest degree term as a common. So that means in this expression, we take 4 as a common. So the remaining expression will become 1 upon 1 plus 5d by 4 plus d square by 4. So this is nothing but the phi d. So that means here our fd will become 1 upon 4, 1 plus something phi d, where phi d is 5d upon 4 plus d square by 4. Now we take this expression into the numerator. So once we take its numerator, this will become 1 upon 4 in bracket 1 plus 5d by 4 plus d square by 4 inverse into x square plus 7x plus 9. Now we will expand this expression by binomial theorem, as we know that the expression of 1 plus x raised to power minus 1 is 1 minus x plus x square minus x cube and so on. So in our case, in place of x, we have 5d upon 4 plus d square by 4. So we expand this expression. So we will get 1 by 4, 1 minus x. Here in this expression, 1 minus x. So this will become 1 minus 5d by 4 plus d square by 4. Second term is plus x square in this expression. So this will become 5d by 4 plus d square by whole square. And now this third term is minus x cube, but we are ignoring here. The reason is that if we see this expression, this polynomial x square plus 7x plus 9, as we have discussed in successive differentiation, this expression can be differentiated maximum 2 times. More than 2 times, the value of this differentiation becomes 0. For example, if we write dqx square, this comes out to be 0. That means x square can be differentiated twice, maximum twice. So for example, once we expand third term, so all the terms we will get will be of the order dq. dq and higher. And once we apply those terms on this function, second degree polynomial, they will become 0. So we are ignoring the higher term. So we are only considering this much of term. So let us simplify this expression to 1 by 4. 1 minus, we are taking this minus sign inside, minus 5d minus d square by 4, plus now we are expanding the whole square of 5d by 4 plus d square by 4. We get 25 by 4 d square plus d raised to power 4 upon 16 plus 5 upon 8 dq into x square plus 7x plus 9. As I said you earlier, x square plus 7x plus 9 can be differentiated 2 times at most. So that means this expression will become 0 and this expression has no meaning. So we are ignoring these factors and we are simplifying these two factors, d square factors. And after simplifying, we get the expression 1 by 4, 1 minus 5d by 4 plus 21d square by 16, x square plus 7x plus 9. Now we are expanding this. This x square plus 7x plus 9 is multiplied by 1. This is first factor. This expression multiplied by 5 by 4d. So that is 5 by 4d x square plus 7x plus 9. Similarly, 21 upon 16 d square x square plus 7x plus 9. So the first term is as it is. And in the second term, this is d of, that is derivative. D stands for derivative of x square plus 7x plus 9. So we will get 2x plus 7. So once we simplify this expression, we will get 2x plus 7. Similarly, d square of x square plus 7x plus 9, this comes out to be 2. So we are putting it here 2. Why we ignore dq terms? The reason is simple. Once we consider dq term, we will get this quantity, that is x square plus 7x plus 9, and we are uploading dq, that is we are differentiating this term thrice, we will get 0. Similarly, d4, d5, all are 0. So we are not considering here. Only we are considering we are limiting ourselves up to the term of d square. So this is here. Now simplifying this whole expression. So this is x square only once. This is here. The coefficient of x, this is here. The coefficient of x is here. Once we simplify this, we will get 9 by 2. Similarly, constant term, this is here, 9. And this expression is here. Once we simplify this, we get this. So ultimately, after simplification of this expression, we get pi is equal to, this is x square plus 9 by 2x plus 23 by 8. So the complete solution will be CF plus pi. So you will calculate CF and the pi part is 1 by 4 x square plus 9 by 2x plus 23 by 8. So this is the complete solution. So far in our 3 videos, continuous videos, in first we will discuss when our fx was e raised to power 2x. Second case we discuss when fx is equal to cos ax oblique sin ax. In third, we have discussed this fx is some polynomial type of function, that is x raised to the power m. In the next videos, we will discuss when fx is the combination of these 3. That means what would happen if our fx is of the form e to the power ax into sin bx. This is multiplication. Or e raised to power ax x to the power m. That means the combination multiplication of exponent and algebraic term. Or what would happen when there is a fx is of the form some x into sine or cos x. That is polynomial term. and this is trigonometric term. So in our next video, we will discuss all these three aspects and another case when fx is something trigonometric functions like sec x, or sometimes it is log x, or any other function of x. Then how to find the pi. And as far as the differences are concerned, these are some books which you can consider as a textbook and the reference book. This is V.V. Raman, V.S. Grewal, Jan and Iyengar, Irvin Kreisig, Peter O'Neill. These are the books basically which we used in the whole this discussion. Thank you.